A group of 15 people consists of one pair of sisters. One pair of sisters. That means in this case, one pair of sisters. A set of three brothers. That means this would be two sister, three brother, and then 10 other people. 10 other people. Total 15 peoples. The 15 people are arranged randomly in a line. Find the probability that the sisters are next to each other. All right. Therefore, I think in this case you can same thing. We can do the arrangement first. The two sister, I call them S1, S2, right? And then the remaining 13 people, these are the remaining 30 people, that means 13 people. All right. That means you can actually arrange these so-called 14 objects. Or then the number of arrangement. Number of arrangement, that will be just equal to what? Number of arrangement, that will be just equal to 14 factorial, right? But the thing is, sister 1, sister 2. It can also be sister 2, sister 1. Therefore, you multiply by 2. All right. And then what is the probability that you want? The probability means that the sample space is actually just arrangement of these 15 people. Therefore, this is 15 factorial. And the numerator, which is actually 14 factorial multiplied by 2. Therefore, in this case, can you see that 14 factorial and 15 factorial cancel? You will get 15, and then this part is 2. All right, the numerator is 2. That's it. Therefore, this is part 1. Sorry. I write wrongly. Okay, this is part 1. Okay, let's look at part 2. Part 2, they say find the probability that the brothers are not all next to one another. Therefore, I think this part is a bit tricky. Are not. Therefore, in this case, we find the case whereby they are next to each other. They are next to each other. That means in this case, number of arrangement. That the three brothers are next to each other. That will be just equal to what? In this case, the three brothers, I call it B1, B2, and B3. They are all together. And then the remaining 12 people. That means the remaining 12 people, as there are 12 remaining peoples, right? And in this case, this is treated as 13 objects. Therefore, the number of arrangement of this 13 object is 13 factorial. But the thing is, B1, B2, B3. What is the number of arrangement among the three? That will be another 3 factorial. All right. That is the arrangement. Okay. And okay. Therefore, number of ways or arrangement that not all three. According to the question, is they are asking for the brothers are not all next to each other. That the brothers, number of ways that the brothers are not all next to each other. Not all next to one another. Okay, take note. I think you must be aware that when they say not all next to one another, it can be the case of brother 1, brother 2, and then there's other people, and then followed by brother 3. This kind of arrangement is actually allowed in this question, right? Therefore, number of ways that the brothers are not all next to each other is actually 15 factorial minus the case whereby all the 3 brothers are next to each other, which is 13 factorial multiplied by 3 factorial. Right? Therefore, the probability is actually 15 factorial minus 13 factorial multiplied by 3 factorial divided by 15 factorial. All right. Therefore, in this case, can you see that this will be 1 minus 13 factorial multiplied by 3 factorial divided by 15 factorial. Then in this case, what do you get? You can see that 13 factorial and 15 factorial, you can do some cancellation. You'll be left with 14 multiplied by 15, and then on top is 3 factorial is actually 6. Therefore, in this case, what you get is 1 minus over 35, and then that will give you 34 over 35. That's it. Okay, let's look at part 3. Part 3, find the probability that the sisters are next to each other and all the brothers are all next to one another. Therefore, again, the idea here is that you tie the two sisters together. The two sisters, S1, S2, you tie them together. The 3 brothers, B1, B2, and B3, you tie them together. Alright, you tie them together. That means B1, B2, B3, B3, you tie them together. Alright, then there are other 10 people. 10 people. Therefore, in this case, can you see that how many blocks of objects? Total, there are 12 objects. 12 objects, right? But again, sister 1, sister 2, it can be sister 2, sister 1. And then the number of arrangement of the brothers is actually 3 factorial. Therefore, number of ways. Number of ways such that the sisters are together and also the brothers are all together is actually 12 factorial multiplied by 2 factorial multiplied by 3 factorial. Therefore, and the probability. The probability would be 12 factorial multiplied by 2 factorial multiplied by 3 factorial divided by 15 factorial. Therefore, what you get here is actually, okay, the denominator will get you 13, 14, and 15 because 12 factorial and 15 factorial, you can do some cancellation, right? And then 2 factorial is basically 2, and then 3 factorial is actually 6. Therefore, what you get here is, when you simplify, is 2 over 455. All right. Okay, now we come to part 4. Part 4. Okay, part 4. Find the probability that either the sisters are next to each other or the brothers are all next to one another or both. Or both. Therefore, in this case, the probability is what? The probability is just equal to what? It is actually, when the sisters are next to each other, is actually 2 over 15. When the brothers are next to each other, is actually 34 over 35. But the thing is, when you add up these two, there are cases whereby the brother and sister are all next to each other. All right. That means there are cases like this. Therefore, this part is the one that is double count, right? This is the one that is double count. Therefore, in this case, the probability required for part 4 is simply 2 over 15 and then plus what? Plus, okay, okay, take note. Okay, take note, class. Part 2, the probability that the brothers are not all next to one another. Therefore, what is the probability that they are all next to one another? All 3 brothers are next to one another. Is actually 1 minus 34 over 35, right? And that will be 1 over 35. Therefore, in this case, it is actually the case whereby the 2 sisters are next to each other, plus all the 3 brothers next to each other. But the thing is, there is a overlapping cases whereby the brothers, the sister and the brothers are also next to each other. Therefore, you should minus away that means it's like this is the sister together, right? And then this is the brother together. B1, B2, B3, right? But the thing is, there is a case whereby both brother and sister are next to each other. And this is the middle part that is counted twice. Therefore, you must take away 2 over 555. 455, sorry. And in this case, the answer is 43 over 273. That is your part 4. All right, now we look at part 5. Find the instead the 15 people are arranged in a circle. Find the probability that the sisters are next to each other. All right. Therefore, again, can you see that the sisters are next to each other, but therefore we treat them as one bundle, sister 1, sister 2, and then plus 13 people. 13 people. Okay, then in this case, we have 14 objects. And the arrangement of 14 objects around a circle is actually what? Is actually, can you see that number of ways? It is actually 14 minus 1 factorial. But the thing is, when we say sisters are next to each other, it can be S1, S2, or it can be S2, S1. Therefore, you multiply by 2. All right. And then the probability. What is the probability? The probability, what is a sample space? It is actually the how you arrange 15 people in a round circle. That will be just in a circle, that will be 15 minus 1 factorial. All right. And then on top, at the top is actually numerator is 14 minus 1 factorial multiplied by 2. Therefore, what you get is 13 factorial multiplied by 2 divided by 14 factorial. Divided by 14 factorial, therefore you just get 2 over 14. That's it. And in this case, 2 over 14 is actually 1 over 7. That's it.